Hello everyone, my name is Parmida Heydari. Today we are going to learn Kubernetes workloads. And also we will learn deployments, StatefulSets, and DaemonSets. A workload is a component on Kubernetes. You run it inside a set of pods. Kubernetes provides several built-in workload resources, such as deployment. Deployment is a good fit for managing a stateless application workload on your cluster. A StatefulSet let you run pods that track a state. If you want to record data persistently, such as database, you can run a StatefulSet. DaemonSets let you define pods on each node. For example, if you want to run an agent on each node, you can define a DaemonSet. Jobs. You use a job to define a task that you run just once. You can use a cron job to run the same job multiple times. Let's take a look at deployment. A deployment manages a set of pods to run an application workload. It provides some features like rollback. You can easily roll back to previous state. Scaling. You can easily scale your application up or down. Let's create our first deployment. Here I have a deployment file. By applying this file, I will create 3 different Nginx pods because I define replicas up to 3. And my image here is Nginx 1.40.2. By running kubectl apply, I create a deployment. And by running kubectl get deployment, we can see Nginx deployment. By running kubectl get pods, we can see 3 Nginx pods. By running kubectl scale deployment, we can scale our applications. Here I scale it up to 4. Now I have 4 Nginx pods. By running kubectl set image, we can change our image tag. For example, Nginx 1.60.1. Now new pods getting created. By running kubectl rollout, we can roll back to previous version. By running kubectl describe, we can take a look at deployment description. By running kubectl set resources, we can define resources for our pods. CPU up to this and memory up to this. Rolling up strategies. We can define rolling up strategies to replace old pods by new ones. There are 2 built-in strategies. Recreate deployment. All existing pods are killed before new ones are created. And rolling update deployment. You can specify max unavailable and max search to control the rolling update process. Max available specify the maximum number of pods that can be unavailable during the update process, while max search specify the maximum number of pods that can be created over the desired number of pods. Let's take a look at StatefulSets in Kubernetes. A StatefulSets runs a group of pods. This is useful for managing applications that need persist storage. StatefulSets require a headless service. Deleting or scaling a StatefulSets will not delete the volumes. This is done to ensure data safety. We will take a look at volumes in the future. Look at this example here. We have a headless service when we define a cluster IP equal to none, and we have a persistent storage here. We have a storage class. We will take a look at a storage in Kubernetes later, but keep in your mind how a StatefulSets work. Persistent volume claim retention policy controls how PVCs are deleted during the life cycle of a stateful set. These policies only apply when pods are being removed due to a stateful set being deleted or scaled down. Policies are retained when deleted, when scaled, or delete. Retain policy is a default policy. PVCs are not affected when their pod is deleted. Let's take a look at DaemonSet. A DaemonSet defines pods that provide node local facilities. A DaemonSets ensure that all nodes run a copy of a pod. As nodes are added to the cluster, pods are added to them. As nodes are removed from the cluster, those pods are garbage collected. Some typical uses of DaemonSet are running a cluster storage daemon, running a logs collection daemon, or running node monitoring daemon. Here there is an example of FluentD, which runs as a DaemonSet. FluentD is an open source data collector that helps unify the logging layer across various systems. It is designed to handle a log data from multiple sources, process it, and route it to various destinations. What is static pods? It is possible to create pods by writing a file to a certain directory watched by kubelet. These are called static pods. Static pods cannot be managed with kubectl or other Kubernetes API clients. Static pods are useful in cluster bootstrapping, however, they may be deprecated in the future. Before finishing workload resources, let's take a look at auto-scaling. With auto-scaling, you can automatically update your workloads. You can scale a workload depending on the current demand of resources. When you scale a workload, you can either increase or decrease the number of replicas managed by the workload, or adjust the resources available to the replicas. Scaling workload horizontally. In Kubernetes, you can automatically scale a workload horizontally using a HPA. Scaling workload vertically, you can automatically scale a workload vertically using a VPA. Unlike the HPA, the VPA doesn't come with the Kubernetes by default. Auto-scaling based on cluster size. For workloads that need to be scaled based on the size of the cluster, for example, cluster DNS or other system components, event-driven auto-scaling, it is also possible to scale workloads based on events, for example, using the Kubernetes event-driven autoscaler. Auto-scaling based on schedules. Another strategy for scaling your workloads is to schedule the scaling operation. Scaling your cluster infrastructure, you can also scale your cluster infrastructure itself. Scaling the cluster infrastructure normally means adding or removing nodes. I hope you enjoyed this video. Don't forget to subscribe my YouTube channel.